ಸ್ವಲ್ಪ ಹತ್ರ ಇಟ್ಕೊಂಡು ಮಾತಾಡ್ತೀನಿ.
Hello everyone, my name is Shubham M. I'm pursuing my engineering at Oxford College of Engineering. Today I got the opportunity of doing an internship in emertxe. So I'm very thankful for the company. So and we have three in a group. Other two teammates are Ujjwal BN and Tanusha. And the overall in this internship we studied about this introduction to C data types and other operators and variables, array and pointers, functions, strings, storage classes, and condition loops, introduction to embedded system and microcontrollers, and GPS versus embedded system. And we have used the tools like MPL, MPL Lab and XC8 compiler, Pixim Lab, uh, where MPL Lab is used to write codes and a compiler is used to compile the program, as you know, and the Pixim Lab is to use whatever the code we have written to execute the code. We have used this Pixim Lab, and next we have learnt about this introduction to various peripheral of 16F877A microcontroller and a project regarding and designing over that embedded systems and embedded C program for the interface of matrix matrix keypad and 16 to 4 LCD, LEDs, buzzers, and coolers, etc. And we have gone through the Disha workshop where we learnt about our career building and resume preparation, etc. This overall view we have in this internship. And coming to the introduction, what is embedded system? Embedded system is a specified computer system designed to perform a specific task within a large device or a product. For example, like washing machine, where it is specified to perform a specific task like washing clothes, and anti-lock braking system ABS. You can see this in thing in all the vehicles. And coming to next is microcontroller. Basically, microcontroller is a chip, computer on a chip. Uh, Computer on a chip. It consists of CPU, RAM, input-output devices, ROM, timer, and serial ports. Next, we can see the difference between GPS and embedded system. Uh, GPS is nothing but general purpose computer system. In this, the a system which is combined of general hardware and general purpose operation system. In embedded system, there is only a hardware and an embedded OS. In this, it contains general purpose operating system. In embedded system, it may or may not contain operating system. Uh, Application in a general purpose computer, applications are alterable. In embedded system, the firmware of the embedded system is pre-programmed and it cannot be altered. Key factors of general purpose computer are: performance is the key factor. In this, application is the key factor. In general purpose computer, more power consumption will be there, and in embedded system, less power consumption. And no time response is critical in the general purpose computer, and in embedded system it is critical. And execution need not to be deterministic in the general purpose computer. In the embedded system it should be deterministic, and like hardware real time system. And in Pixim Lab, this is a basically hardware. We have used a Pixim microcontroller Pix PIC16F877A and an LCD display, and keys, buzzers, fans, timer. Basically, this Pixim Lab consists of these things, and this is the architecture of the Pixim Lab. We can see the LEDs, buzzers, and all other things, and pin configuration of the pin. This is the pin configuration of the microcontroller which we have used. This is a 40 pin IC. Each pin has a separate working process according to it. I will be explaining the next slide. The first pin is the master pin, which is input or voltage pin, used to reset the microcontroller and can be used as external programming. Second pin is analog input channel zero pin or a digital input pin, can be used as a digital input or output. And pin 3 is analog input channel 1. It is also same as similar as RAO, the previous pin. And pin 4 analog channel 2. All these things are similar. And coming to pin 5 analog input channel 3, reference to voltage, capacitor connections, etc. All the connections can be done here. And pin 6 timer 0 or clock, whichever the source we have to give, we can give to the pin 6. And pin 7 analog input channel 4, slave select, high low voltage, etc. And pin 8 is port E bit 0, it is a read write control signal. And pin 9 is port E bit 1, write control signal along. And pin 10 is port E bit 2, chip select system in this. And pin 13 is external oscillator input or clock input. And pin 14 is external oscillator input output or clock output. And pin 15 is timer 1 oscillator output. And pin 16 is timer 1 oscillator input. And pin 17 is capture compiler, etc. And pin 18 is synchronous serial clock. And pin 19 is serial data output. And this pin 20 is serial data input. Pin 20 is transmission data. Pin 22 is receive data. Pin 24 is supply voltage. And pin 25 is uh, interrupt input. And other pins are the basic pins you can see in the slide. Coming to the next, you can see the ground pin in 35. Sorry, ground pin in 34. Supply voltage in 35 and 33 as well. And other ground pin in 36. And 37 is the in circuit serial programming data. And 38 is in circuit serial programming clock. And pin 39 is keyboard interrupt. And pin 40 is capture, again the same thing. These are the pin configuration of the uh, pin combination of the microcontroller we have used. And now coming to next, it is a microwave. Basically we have done the project on the microwave oven. It is a microwave oven is an oven which cooks food very quickly by radiomagnetic radiation. Sorry. Electromagnetic radiation rather by heating. Basically, it is cooking by heat, radio magnetic radiation. Uh, that's and in this, we have done four modes. First mode is micro mode. In a micro oven, the default mode is micro mode, cooking mode, which uses microwave radiation to heat or cook food. And next, micro mode is maximum to 900 watt. Next mode is grill mode. Microwave oven, the grill with the grill or function have heating element on the top or bottom to help brown the crisp and surface of the food. And above the means basically it is used to cook the food above and down. Uh, that's all. And next is convection mode. Some microwaves oven basically we will before cooking we will heat the oven to certain temperature required. And next is the start mode. In this, the before cooking the oven will be set to certain limit of time. So we have given 30 seconds, and 30 seconds will be heated by this oven. And these are the requirements of our project: basic embedded C, pin configuration, MP lab, and compiler, and Pixim lab. In Pixim lab, we have PIC 16 F877A microcontroller, 16 to 4 LCD, matrix key, cooler, buzzer, etc. Now I will show you the uh, program which we have used in this. Uh, okay. Let's go to the program. This is the program we have used. We have given the header file as a main.h, and many other header files are there. You can see this, and we have given the each header file as it is been defined, and each what do you say, each system has been defined and each number we can according to the pins of the IC. You can see over here. And coming back to the program, at initial it will be 0 and everything will be in 0. When at first we have to give the let me explain the modes over here, and I will explain the operation in the uh, working fixing lab. uh, Modes are like, first when you press key 1, it will go to the micro mode, you can see here. And if you press key 2, it will go to the grill mode. And if you press key 3, it will go to the convention mode. And if you press key 4, it will go to the start. That's all. And other things are the program, how it will running. Okay, let me show you the working of this. At initial, it will be showing you like this. At first, if you press 1, it will go to the micro mode, where the maximum power is 1900 watts. If you set the timer to 10 seconds, I will be setting the timer to 10 seconds. And this star is for clearing, and this hash is for entering the number. Now I will press enter. When I press enter, the fan will be starting, and the timer is start, and you can see the timer is running. And after the 10 seconds, the buzzer will be beeping. You can see the buzzer beeping. Uh, Then we have done the micro mode. Next, go to the grill mode. See, when I press key 2, it will go to the grill mode. I can insert the time, seconds, whatever I want, in minutes or seconds. I'm setting in for 10 seconds for now. Let's enter. So again, the fan is running, and you can press 4 for resuming the time, incrementing for 30 seconds. If you press 4, it will be incrementing. If you press 5, it will be paused. And if you press 6, again, if you press 4, it will be resumed. If you press 6, the operation will be stopped. I will press 6, so the more time it will consume, so I will stop this operation. So grill operation is come done, and now I will show you the third one, grill convention. You Initially, we have given the 180 degree Celsius maximum. If you see, I will show you 190 Celsius I will be giving. It will show low should be the less than or equal to 180 Celsius. So I will give around 50 degree, and I will press enter. And we have given the initial timer for setting, and given the temperature setting for 18 seconds. Now 18 seconds. Let's wait for the another 8 more seconds till the temperature comes. And now you can set the timer. I will set it for 10 seconds. I will enter, and timer is begun and the fan is running. This is the 4, 5, 6 are the I have shown you previously same operation. Increment, pause, stop, resume. After completing, the beep will be starting. You can see the beep. And next is the last mode, start mode. In this, initially you can see we are given the 30 seconds timer. It will start from 30 seconds. If you press 4, it will be incremented to the plus 30 seconds. If you press 5, it will be paused. And if you press 4 again, it will be resumed. And it takes more time, so I will be pressing 6 to stop this. See, you can see this, it has been stopped. So this is the project we have done in this. So I'm very thankful for emertxe team for giving me this opportunity for doing this project. So I'm very grateful for you. Thank you very much. Thank you, Fernando.